In this video, I'm going to look at one of the applications of differentiation, and that is the use of differentiation in maximum-minimum type problems. In this problem, an open box is to be made from a roll of metal 2 meters wide, as in the diagram. And the first part of the question asks us to write down an expression for the length and width of the box. When folded up, the length and width of the box will be the dimensions marked L and W on the diagram. And we can see by inspection of the diagram that the length is going to be the length of the roll Y minus 2 lots of X, and the width will be the width of the roll 2 meters minus 2 lots of X. Second part of the question asks, if the box is to enclose a volume of 8 cubic meters, find a rule that links X and Y. So let's just consider what the box looks like when it's folded up. It will have base dimensions of W and L, and it will have a height of X. Now the volume of the box is given by the area of the base by the height. Here the height is just equal to X, and the base is equal to L by W. Now because we have an expression for L by W earlier on, that's equal to Y minus 2X by 2 minus 2X. So the volume will be the product of the length by the width by the height. In other words, it's 2 outside of Y minus 2X, so 1 minus X by X. That's factorising one of the brackets there. Now if we substitute 8 for the volume, we get 8 equal to the length by the width by the height, or 8 equals 2X outside of Y minus 2X outside of 1 minus X. Now we can cancel both sides by a factor of 2, and that gives us 4 equal to X outside of expanding the binomial brackets now, Y minus XY minus 2X plus 2X squared. Just going to move this to the top of the next page. Taking X through the brackets now, we get 4 equal to XY minus X squared Y minus 2X squared plus 2X cubed. Now because we're looking for Y, we need to factorise the Y terms. So we take Y out of the first two terms of the right hand side, and we get the expression 4 equal to Y outside of X minus X squared minus 2X squared plus 2X cubed. Taking the X terms over to the left now, we get 4 plus 2X squared minus 2X cubed equals Y outside of X minus X squared, and that allows us then to find Y by itself, just dividing both sides by X minus X squared. Gives our final expression for Y, 4 plus 2X squared minus 2X cubed over X minus X squared. Now in order to express this as partial fractions, we need to divide out the numerator by the denominator, and we need to do that by long division. So let's just sketch out the long division. We're going to divide negative 2X cubed plus 2X squared plus 4 by negative X squared plus X, just so that we've got the terms in descending powers of X there, both in the numerator and then the denominator. So starting our long division then, minus X squared goes into minus 2X cubed 2X times. Multiplying back across, we get 2X by minus X squared equal to minus 2X cubed, 2X times X equal to plus 2X squared. And when we subtract those from each other, we get 0. So we can write our expression for Y in terms of two partial fractions. Y is equal to 2X plus the remainder, which is 4 in this case, 4 lots of X minus X squared. And we're just factorising the denominator now. 2X plus 4 over X outside of 1 minus X. And that's the simplest expression for the value of Y then. 2X plus 4 over X outside of 1 minus X. Part 3 of the question now asks us to write an expression for the total surface area of the box, and then use substitution to make this a function of X only. Well, the total surface area is the outside surface area. It doesn't include the inside surface area, so it's just focusing on the outside surface area here. And the total surface area, if we look back at our diagram, is 2 lots of w times x plus 2 lots of L by x plus W by L, the area of the base. And we substitute the values we have for L and W, then we get the total surface area equal to 2. So 2 minus x by x plus 2 outside of y minus 2x by x plus 2 minus 2x by y minus 2x. And now we carefully need to expand those terms and eventually collect the like terms. So just carefully expanding, we'll do the inside brackets first. First line, 2 outside of 2x minus 2x squared plus 2 outside of xy minus 2x squared plus 2y minus 4x minus 2xy plus 4x squared. And then doing our final expansion there now, take the 2 through the brackets, 4x minus 4x squared, take the 2 through the brackets again, 2xy minus 4x squared, plus 2y minus 4x minus 2xy plus 4x squared. Extremely careful with our signs here, we don't want to lose a negative sign. Let's collect the like terms. There's a minus 4x squared and a plus 4x squared. They'll cancel out, they'll disappear. There's a plus 2xy and a minus 2xy. They'll also disappear. There's a plus 4x and a minus 4x, and they'll disappear, and that leaves us with minus 4x squared plus 2y for the expression for the total surface area. But we now haven't yet used a substitution, so we need to substitute the value that we have for y. You'll recall that y is equal to 2x plus 4 over x outside of 1 minus x. So we need to substitute that now for the value of y. And we get this expression, minus 4x squared plus 2 outside of 2x plus 4 over x outside of 1 minus x. Tidying this up carefully, taking the 2 through the brackets, we get minus 4x squared plus 4x plus 8 over x outside of 1 minus x. Now you'll notice that's got a common factor of 4. So let's remove a common factor of 4. In fact, we might remove a common factor of negative 4 out here, being very careful not to slip with our negative signs. So minus 4 outside of x squared minus x minus 2 over x outside of 1 minus x. And that's our expression for the total surface area in terms of x only.